Now for the third mechanism that is associated with maintaining the concentration gradient of the interstitium of the medulla for the kidney. And the purpose again for that concentration gradient is so that water can be reabsorbed and enter back in your system. So let's look at this, and you'll see some numbers on here. I'm not so interested in the numbers on every step. Okay, there's a few basic numbers that I'll point out. When we look at the filtration, starting off with the glomerulus, okay? So if we start at the glomerulus, let me just put this in, let me do blue. Blue would be a little bit easier, okay? So here we're at the glomerulus. Yep. Well, if I can get this working. Here we're at the glomerulus, okay? And urea is filtered out. Now again, urea is a waste product of protein metabolism, that we know. It can be toxic in high levels, but it can be very valuable in maintaining the osmotic gradient of the interstitium. So once the urea is filtered out, so this is where we're getting 100%. So whatever's filtered out, that's what the 100% is referring to. In the proximal convoluted tubule, like I said previously, here 50% is reabsorbed from the proximal convoluted tubule. That leaves 50% in the tubular fluid, or part of the filtrate, okay? Now, as that filtrate works its way around, for right now, ignore this part down here, okay? Because like the countercurrent multiplier, countercurrent exchange, this is a cycle. So I want to kind of do a cycle and then show you where it loops back in on itself, okay? So here urea comes around. Don't worry about the 100% right now. Just think 50, okay? This is just to kind of give you a visual. Urea comes in. Then after the loop, nephron loop, it gets into the distal convoluted tubule, which is impermeable to water. Then it gets into the collecting duct, okay? As the urea gets into the collecting duct, some more is reabsorbed by the body, okay? So as it's reabsorbed, don't worry about the numbers right now that you're looking here. It's reabsorbed by the body, so you can see reabsorbed. So urea is going to be coming out, okay? And then the total amount that comes out, it's going to be 55% that's reabsorbed, okay? So starting at the beginning, we filter out urea. 50% of what's been filtered out is reabsorbed within the proximal convoluted tubules. That continues on. And then now we look at the filtrate within the tubular fluid in this region here, okay? The urea from the collecting duct, 55% of that urea is taken out of the collecting duct and reabsorbed. 50% of this 55%, so 50% is brought back into the tubular system. 5% is then taken back to your bloodstream and goes through this process again. Okay, so let's go through some of the key numbers. Here we start off, we filter urea, 50%. That number I want you to know is reabsorbed in the proximal convoluted tubule. So now we have 50% still in the tubular system. It's following the nephron loop. And once we start going back into the thin segment of your ascending limb, that's going to be key. The thin segment of your ascending limb is where urea is secreted into the tubular fluid. Now remember the definitions of reabsorbed and secreted. Reabsorbed means it goes from the tubular fluid back into the body or back into the bloodstream. Secreted means it's going from the body and it's being put into the tubular fluid, okay? So here we've got 50% going down the descending limb. On the thin segment of the ascending limb is where urea is secreted into. So here, 50% of what was reabsorbed from the collecting duct goes back into the tubular fluid. So now we're back at 100%. So 50 plus the 50 here gives you that 100%, okay? So it doesn't make much sense. So if one of your primary components of urea or of urine is urea, and we've got 100% in the distal convoluted tubule, how does it come out in the urine, okay? Well, as it comes down, 15% of the total amount of urea actually comes out in the urine. Since we still have protein digestion, we're still adding more to this, okay? So as we come around, let's go through this real quick. Urea is filtered, 50% is reabsorbed in the proximal convoluted tubule. The remaining 50% goes through the loop. On the thin segment of the ascending limb, urea is secreted into the tubular fluid to bring us back up to that 100% quantity. The thick segment of your ascending limb, the distal convoluted tubule are impermeable to water, so urea stays within this area. It enters into the collecting duct, and collecting duct is where urea is then reabsorbed via uniporters, and it's 55% is reabsorbed. Of that 55%, 50% goes back into the tubular fluid, 5% goes into your bloodstream, and then the 15% is excreted. Now, the importance of urea is in helping to maintain the osmotic pressure. Let me do green. The osmotic pressure in the interstitium. That's all this stuff, okay? And that osmotic pressure is important for reabsorption of water. Okay, so that is urea recycling. So as you can see, the recycling issue, let me just do dark blue on this one. Urea is coming down, comes back in, and it kind of just gets recycled over and over and over, okay? That's kind of the recycling component. The next thing that I want to do, I think I'm going to do just kind of put everything together and how the renal system, as well as other systems, can help monitor and deal with blood pressure.